Welcome to Biosimplified PYQ, where we focus only concept of PYQs. See, here the question is, for a simple enzyme that follows Michaelis-Menten kinetics. Kinetic data was collected in the absence and the presence. In the absence, dotted line like minus I means absence of inhibitor, or presence, solid line, presence of inhibitor plus I of an uncompetitive inhibitor. Which of the following Eddie Hofstadter plots best describe the expected result? We talked about competitive inhibition, and we seen there enzyme and substrate make enzyme substrate complex and then product. In uncompetitive inhibition, inhibitor cannot directly bind to enzyme. No, inhibitor need enzyme substrate complex and then make enzyme substrate inhibitor complex, and that make inactive, and it don't proceed to product. And that is the whole story of uncompetitive inhibition. Because of that, some enzyme substrate are not able to produce product. That's why Vmax decreases and Km also decreases because system tries to form more ES complex to form product. Looks like higher affinity. Then in this situation, Km and Vmax both are decreasing. That most important part, ratio stays same, constant. And that's why in LB plot, it's look like parallel. Now you can see in this question, here is talking about uncompetitive inhibitor, but not asking LB plot. Here is asking EH plots. In EH plot, graph is like presence of inhibitor and absence of inhibitor. It is not parallel, it is intercept on x-axis because here slope is dependent on Km. Km is decreases and intercepts is dependent to Vmax. Vmax is also decreases, but both are decreasing at the same ratio. That's why it intercepts. And major difference is between LB plot and EH plot. LB plot slope is dependent on Km Vmax ratio, and here only Km. Now you can solve this question. Here is EH plot, uncompetitive inhibitor, and answer is D.